All right, for this section, we're going to talk about surface area of revolution. So if F is smooth, that means it's differentiable, there's no sharp corners, and non-negative on some closed interval from A to B, then if we revolve about the x-axis, we're going to be given the surface area is equal to 2 times pi times our integral from A up to B of our function times the square root of 1 plus the derivative of our function, quantity squared. And this is dx. This is when y is isolated. If our x is isolated, we're going to have our surface area is equal to 2 pi from C up to D. So these are our y coordinates. Y times our square root of 1 plus the derivative of our y function, quantity squared, dy. Okay. If we're revolving about the x-axis, so you always want to check to see if it's saying it's revolving around the x-axis or the y-axis. So we have the surface area of 2 pi times a up to b of x times our square root of 1 plus f prime of x quantity squared dx when y is isolated. And then when x is isolated, we have 2 pi from c up to d of our g of y function times the square root of 1 plus g prime of y quantity squared dy. All right, so let's look at an example. The graph of y equals x cubed when x is between 1 and 2, okay, revolved about the x-axis. And let's find the surface area. Find the surface area. Okay, so if you think about y equals x cubed, that's this function. Okay, from 1 up to 2, and we're going to revolve this about the x-axis, and we're just looking at that surface area. We're not looking at the area or the volume, we're just looking at that surface area of that from 1 up to 2. Okay, so from 1 up to 2, and we're going to revolve here, so it's going to kind of make that figure that looks like this, and we're just looking at that surface. Okay, we're not looking at the solid. Okay, so our surface area is going to be 2 times pi times our integral, and it told us from 1 up to 2, 1 up to 2. And because this is about the x-axis, so I look at the x-axis function, and because this is isolated for our x, I'm sorry, our y is isolated, that means it's y equals x cubed. We're going to have x cubed, that's our function, okay, times, so this is going to be times the square root of 1 plus the derivative of that, which is the derivative of x cubed is 3x squared, and that's going to be quantity squared dx. All right, so we have 2 times pi from 1 up to 2 of x cubed times 1 plus, let's see, 3x squared quantity squared is 9x to the 4th dx. All right, so let's see what we have here. So 2 pi from 1 up to 2 of x cubed times 1 plus 9x to the 4th raised to the 1/2, because that's the square root. All right, so we have a little bit of a problem, and that's with this piece here. So I have to do a substitution. I'm going to say u is equal to 1 plus 9x to the 4th. So du is what? That's, 36 x cubed dx. All right, I have my dx and I have an x cubed, but I don't have the 36. So this gives me 2 pi times 1 over 36 from 1 up to 2. So our x cubed dx becomes du, and this is u to the 1/2, u to the 1/2. All right, so let's see, 2 and 36 gives me just pi over 18 times our u to the 1/2 gives us u to the 3/2 over 3/2 from 1 up to 2. Well, this 2 and this 18 cancel, leaving me with pi over, well, that's 9 times 3, which is 27. And my u, I'm going to undo the substitution. So this gives me 1 plus 9x to the 4th raised to the 3/2 from 1 up to 2. So let's see, this is pi over 27 times, well, 1 plus 9 times 2 to the 4th is 1 plus 9 times 2 to the 4th, and that's raised to the 3/2 minus 1 plus 9 times 1 to the 4th raised to the 3/2. Okay, which gives me what, pi over 27 times, so this is 2 to the 4th times 9 plus 1 is 145 to the 3/2 minus 9 times 1 to the 4th, which is just 9 plus 1, which is 10 to the 3/2. And you could leave your answer like that, or you could approximate this to 63.5 pi. Okay. All right, let's try another one. So let's do the surface area. So find the surface area of 4x equals y squared revolved about the x-axis. Okay, so with this one, we neither have x nor y. Oh, I forgot to give you a is 0, 0 from A to B. So A is 0, 0, B is 1, 2. Okay. All right. Since this is revolved about the x-axis, okay, since this is revolved about the x-axis, I can use either when y is isolated or when x is isolated. And I can isolate either one. I'm going to isolate x just so you can see this other function. Okay, so again, this is surface area equals 2 pi from C up to D of y times the square root of 1 plus g prime of y, quantity squared, and that's dy. Okay, this is when our x is isolated. So let's go ahead and do that. So s is equal to 2 pi from our y coordinates, so 0 up to 2. So 0 up to 2 of y times our 1 plus g prime of y. Well, let's go ahead and isolate this. So x is equal to y squared over 4. Okay, so if I found the derivative of that, the derivative of y squared over 4 gives me y over 2. Okay, you can think of this as 1/4 y squared, which gives you, you bring down the 2, so that gives you 2 over 4 y to the 2 minus 1, which is y to the first, which is 1/2 y, which is y over 2. Okay, so that's kind of the, this is x equals x prime. Okay, if you want to think of it that way. So it gives us that y over 2. So that's our derivative. Okay, so our derivative, so x prime equals y over 2. So this is going to be y over 2 quantity squared dy. All right, so 2 pi from 0 up to 2 of y times, I'm going to go ahead and just say that this is to the 1/2. So this is to the 1/2, and then I have 1 plus y squared over 4 raised to the 1/2 dy. All right, let's do a substitution. let's say t is equal to 1 plus y squared over 4. So dt is, well, the derivative of that is just the 1 goes away, and I end up with 1/2 y dy. All right, so this gives me 2 pi from 0 up to 2 of, well, I have the y, I don't have a 1/2, so I have to bring out a 2. Okay, so I'm going to have to multiply that by 2. And then this is going to give me t to the 1/2 dt, okay? Because the dt is our dy times our y in 1/2. So to get the 1/2 here, I have to multiply by 2 out here. And then this gives me t to the 1/2. So this gives me 4 pi. And then t to the 1/2 gives me t to the 1/2 plus 1, which is 3/2 over 3/2 from 0 up to 2. All right, let's clean this up. I'm going to bring out the 2/3, so that gives me what, 8 pi over 3 times t, which was 1 plus y squared over 4 from 0 up to 2. Okay, and that was raised to the 3/2. That was raised to the 3/2. All right, so 8 pi over 3 times, well, I'm going to plug in the 2, and I'm going to go ahead and do this math. 2 squared is 4. 4 over 4 is 1. 1 plus 1 is 2 to the 3/2 minus, well, when I plug in 0, this piece goes away, but the 1 stays there. So this gives me 1 to the 3/2, or just 1. All right, so that gives me 8 pi over 3 times our 2 to the 3/2 minus 1. So that's the square root of 2, quantity cubed. So 2 raised to the 3/2. And then I'm going to subtract 1. Hold on, 2 raised to the 3/2 minus 1 gives me about 1.82, and I'm going to multiply that by 8 pi divided by 3. Okay, which is, I guess I can just erase that. And if my math is correct, you could leave it like this. I would be fine with that. That's approximately 15.3. Again, I would be okay if you had left it like that, or it's approximately 15.3. Okay. All right, the next we're going to talk about arc length. So if this is in terms of x, the length of that arc is going to be a up to b of the square root of 1 plus f prime of x quantity squared dx. So very similar to the surface area. And in terms of y, from c up to d of our square root of 1 plus g prime of y quantity squared g of y. So essentially, arc length is just some length from this AC up to BD. Okay, so let's do an example. Let's do an example here. Let's say find the arc length of y equals 5 minus the square root of x cubed from point A, 1, 4 to B, and we'll say B is 4, -3. Okay? All right, so let's see what we get. So I'm going to do this from our x. So I'm going to say from 1 up to 4 of the square root of, so I'm using that function. So let's see, if f of x is equal to 5 minus the square root of x cubed, so that's x to the 3/2, then f prime of x is equal to, let's see, -3/2 x to the 3/2 minus 1, so that's x to the 1/2. Okay, so this is going to be 1 plus our f prime of x, which is -3/2 x to the 1/2, and that's quantity squared. dx. So you're not going to have a negative under the interval or integral here. So our length here is going to be from 1 up to 4. Now I need to do -3/2 x to the 1/2 quantity squared. Well, that's going to give me a positive 9/4x. Okay, so this is going to give me the square root of 1 plus 9/4 x dx. All right, let's do a u substitution. So du is going to be 9/4 dx. Okay, that's pretty simple. So that gives me, well, I have my dx, but I don't have a 9/4, so I have to bring out a 4/9 because we'll just invert that, because 4/9 times 9/4 gives me 1. And 1 up to 4 of u to the 1/2 du, which gives me 4/9. And u to the 1/2 gives me u to the 3/2, u to the 3/2 over 3/2 from 1 up to 4. All right, let's clean this up. This gives me 8/27 times u. U is 1 plus 9/4 x to the 3/2. And we're going to go from 1 up to 4. So this gives me 8/27 times, well, when I plug in the 4's cancel, leaving me 1 plus 9, which is 10 to the 3/2, minus, well, when I plug in the 1, we have 1 plus 9/4, which gives me what, 13/4 raised to the 3/2 times 8/27. And I think that's approximately 7.6. Let's go ahead and check that. So let's see, I have 10 raised to the 3/2, and then I'm going to subtract off 13 divided by 4 raised to the 3/2. Okay, and then I'm going to multiply that by 8/27, which is about 7.6. Okay, that's what I got. Okay, so arc length is pretty straightforward. Let's do, how about one more of these? Okay. So find the arc length of the graph of y equals 2x from the origin to the point to 4. All right, so we're starting at the origin, so we're going to go from 0, 0 to the point 2, 4. Okay, so this is our A, this is our B, okay? Or C up to D if you decide to do it that way. So I'm going to say the length is equal to the integral from 2 up to 4 of our 1 plus f prime of x, because this is isolated for y. So 1 plus our f prime of x. So y prime is equal to 2. Okay, so this is 1 plus 2 quantity squared dx. Okay, because remember this is A up to B 1 plus f prime of x quantity squared dx. Well, the derivative just happens to be constant, so that worked out nice. So this is 0 up to 2 of the square root of 4 plus 1 is 5, and that's dx. Now remember that since there's no function of x here, I can factor out that square root of 5. So this is just 1 dx, which gives me the square root of 5 times our x from 0 up to 2. Okay? So this gives me the square root of 5 from 2 minus 0, because all we have is x, so that gives me 2 square roots of 5. Okay? 2 square roots of 5. All right. If I could have used the distance formula just to get you to kind of think about really what's happening here. Because let's see, y equals 2x. So this is y equals x. 2x goes a little bit faster toward the y-axis. And this is from the point 0, 0 to the point 2, 4. So from here, from there to there, I could have used the distance formula. Okay, so that's 0 up to 2. I could have used the distance formula. So that's x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared for this one, because this is just a straight line. So that gives me what? 2 minus 0 squared plus 4 minus 0 squared, which is 2 plus 4, which is the square root of, not 4, 4 squared. I just realized that as soon as I wrote it, I was like, wait a minute, that's not right. This is 4 plus 16, which is the square root of 20, which is, if I factor out a 4 here, square root of 4 is 2, 2 square roots of 5. So we end up with the same answer when we do an arc length of a straight line. Okay, so that just happened to work out nicely for us. All right, so that concludes this lecture. We have work next and Hooke's Law. So make sure to watch that video.